Hi girls, now let us continue the last class topic, that is the level of the tree. The level of the tree is nothing but it's a rank in the hierarchy. The root node has a level 0. If a node is level L, then its child is at level L plus 1. The parent node is the level L minus 1. This is the level of the tree. Okay, now let us see the height of the tree. The maximum number of nodes that is possible in the path starting from the root node to leaf node is called as height of the tree. This height of the tree is indicated with the h equal to L max plus 1. Okay, now here h means nothing but the height of the height, indicated the height. Next L max is the maximum level of the tree. Now degree of the tree. The maximum number of childs that is possible for the node is known as the degree of the tree. Already we discussed in the last class, the degree of the node is nothing but except the root node, how many levels are there, then we continue the counting up to 0, 1, 2, 3 up to n, like that. The degree of the node is indicated with the D. Next, sibling. The node which have the same parent are called sibling. This is the basic terminologies of trees. Now let us see what is a tree definition. A tree is a finite set of one or more nodes is called as a tree. So here let's look at the picture. Here the A is a root node and it consists of three subtrees, that is T1, T2, T3. So T1 again having the number of child nodes, it is called as left subtree. It's called as left subtree, and T3 is called as right subtree. Okay. Now let us see what is the binary tree. Okay, so here the binary tree is a special form of a tree. Okay, it is a special form of a tree. A binary tree can also be defined as the finite set of nodes such that capital T. T is empty, called as the empty binary tree. Tree contains specially designed node called the root of the tree, and the remaining nodes, that is the remaining nodes B, C, D, F, E. Here remaining nodes is there na. So these remaining nodes of the T form two disjoint binary trees, that is called as T1 and T2, which are called the left subtree and the right subtree respectively. So here let us we see the two types of binary trees. One is the full binary tree, another one is the complete binary tree. A full binary tree is a full binary tree if it is contain the maximum possible number of nodes that are called the levels. Okay, it is called as the full binary tree. Next, let us see the complete binary tree. So here a binary tree is said to be complete binary tree if all the levels except possible the last level is called the complete binary tree. Look at the picture here. It is a binary, full binary, complete binary tree. Here the root node is indicated with the level 0. So level 0, 1, 2, 3. Okay, here having the number of levels is 4 levels, and each level having the how many nodes? Let us see here. Level 0 having the 1 node, and level 1 having the 2 nodes, and level 2 having the 4 nodes, and level 3 having the 8 nodes. That is 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is called as the differentiation of the full binary tree and the complete binary tree. Okay, now the trees are represented with the two ways. One is the linear representation, another one is the linked representation. Here linear representation is nothing but which use the array representation. It is called as sequential representation also. So it follows some of the rules, that is while representing in the linear form, the rules are the root node is the location L. Next, for any node which index I, L is less than I is less than n for the sum 1. Here look at here the parent node and left child and right child. Parent node I equal to I by 2 for the node when I minus 1 there is no parent. Now let us see the left child of I is calculated with the 2 into I. If 2 into I is greater than n, then it has no left child. For coming to the right child of I, 2 into I plus 1, if the I into 1 plus 1, 1 is less than n, then it has no right child. Okay. Now let us see the link representation. You already see that In a ring representation, the linear representation is a binary tree has a number of overheads. In the link representation of a binary tree, all these overheads are taken care of that one. Okay, we already see that link representation. We in the last classes, link representation is having the main advantage. We can extend the memory locations. Okay, here let us see the node structure. Node having the tree parts. One is the right child part, another one is the left child part, and the middle of is indicated with the data. Okay, here look at the tree, binary tree with the symbols. It's a array, it's a representation, physical view of representation and logical view of the representation. Here let's look at these nodes, right child and left child. Each node having data is indicated in the middle of the node. Okay, based on this address we can locate the nodes. Now let us see the logical view of this one. Here the root node indicated with the plus, that is the right child of this node, that is a minus, has linked with like that, and into right child is indicated with like this, and continuously based on the locations we just allocate the child nodes in this picture. Okay, now let us see the advantages of sequential representation of binary tree. Here, any node can be accessed from any other node by the calculating the index, and this efficient formats execution point of view. Here, only data are stored without any pointer to their successor and ancestor, which are mentioned implicitly. Okay, these are the advantages of sequential representation. Thank you.